Hi, in this video we are going to discuss the basic propagation mechanism. Propagation means transmission of a wave from the transmitter to the receiver side. That is propagating. The wave is propagating from a transmitter to the receiver. So the mechanism involved in that is called as the propagation mechanism. Okay. So what this image indicates, you have any idea? Okay, so what this rainbow waves indicates? So this is nothing but all are wireless communication. So the waves are moving like this. So this is called as the propagation of waves. And you know the wireless communication, the waves are propagated by means of an electromagnetic waves, isn't it? They are propagating as a electromagnetic waves. Okay, so here the term radio waves are nothing but represent the electromagnetic waves which is in the frequency range of 0.001 Hertz to 10 to the power 16 Hertz, where the wavelength is ranging from 3 to 10 to the power minus 8 meter to 3 into 10 to the power 11 meter. So look at here, since it is an EMF wave, you have an electric as well as a magnetic wave. Both are perpendicular to each other. So a radio wave which comprises of both this electric wave as well as the magnetic waves. So this is the classification of a radio waves. So it starts from extreme low frequency where a frequency range is less than 3 kilohertz and a wavelength is greater than 100 kilometer. While you are traveling in this direction, that is increasing bands, the frequency range is continuously increasing, whereas the wavelength is continuously reduces, because we know the relationship between the frequency and wavelength. So from extended low frequency, it's moved to very low frequency, medium, and it extended as up to the extreme high frequency, where the frequency range is 30 to 300 gigahertz and wavelength is about 1 mm. So these are the various ranges of frequency from very low frequency to the extended low frequency, and their applications in a communication and their wavelength and a corresponding frequency ranges. So in the low range frequencies we are using for a radio propagation and navigation, whereas in the middle wave we are moving to the television, FM radio and Wi-Fi, GPS, 4G, and the higher range we are using for a satellite communication and radio astronomy applications. So these are the classification of radio waves and their applications on a different bands. And about propagation mechanism, we know that LOS propagation is nothing but line of sight propagation. That is, there is no obstacle present in between the transmitter and to the receiver. A clear, unobstructed path exists between the transmitter to the receiver. Then that kind of propagation is called as a line of sight propagation. So there are three basic propagation mechanisms involved in transmission of electromagnetic waves. Those are listed as reflection, diffraction and scattering. So we will see one by one. So look at this image. So this is the direct line of sight exists between the transmitter to the receiver. There is no obstruction exists. That's why it is called as a line of sight. And reflection, diffraction and scattering are the different phenomena we will discuss in the later slides. So line of sight transmission is a type of propagation where transmission and receiving antennas are in view with each other. There is no kind of obstacles exist between them. The best example is your FM radio, microwave and satellite transmissions. So we do this activity, then we move on to the next part of our PPT. First we go with the phenomena called as a reflection. So you might have studied these phenomena in your physics itself. So reflection is nothing but an abrupt change in direction of a wavefront at interface between the two similar media. Suppose your wave incident on the smoother surface, it tends to reflected back, isn't it? So that the wavefront returns into the medium from which it is originated. So this is called as a reflection phenomena. So this reflection is the result of digital TV signals which is hitting on the obstructions with properties where thickness and length are much larger than the wavelength of radio waves. So in this case, the waves are just reflected back. And in case of an diffraction, it occurs when your signal encounters on the edges or a corner. That is when it hits on the sharp edges like hills, trees or any towers. In this case, a diffraction phenomena will be present. Here the consideration is size is larger than the wavelength of the signal, that is edge of your building roofs and in mountain tops. These act as exactly as secondary sources and re-radiating into the shadowed region. Suppose your waves are hitting on these edges, the spot will act as a secondary source and this will generate a wave again and will transmit to the unreached portions. So that is the main advantages of this diffraction. Okay, suppose when there is no line of sight exist between the antennas in the urban areas, this diffraction effect will reach the radio waves to the unreached places. And about scattering, it occurs when a signal encounters small objects of size which is smaller than the wavelength of the signal. Okay, due to this, a disordered or a random change in the energy distribution occurs. See here, when it is hits on a smooth surface, there is a reflection. When it is hit on a rough surface, then it will be scattered. Okay. And another important concept in a wireless communication is the multipath propagation. So from the name itself, you might understood a wave in a wireless communication take a multiple path. That's why it is called as a multipath propagation. So see here, wave is generated at this point. It may be hit on a smooth surface where it is reflected back, or it may be hit on the top of the edges of a high buildings where it may be diffracted, and there is some possibility for a line of sight, and sometimes it may hit on a trees where a scattering effect will taken place. So finally at the receiver we might receive the signals from all this, apart from a line of sight and due to diffraction, due to scattered and due to reflection. So all these waves will be collected at a receiver, so which is called as a multipath propagation. That is, we are receiving a multiple copies of a signal propagation which take multiple path while arriving at receiver, and also these signals are received at different times. So signal received at a point affected by the interaction of signals which propagated along the multiple paths. And one more thing consider in this multipath propagation and wireless communication is a fading effect. So fading is losing of a signal strength, loss of a signal strength. So here we consider that it is a small scale fading. As a name indicates, it's to be happened over a shorter distance and you have a random fluctuation. So then that kind of fading is called as a small scale fading, and it depends on the propagation environment. So the two parameters about this is a short distance and a short period of time and random fluctuations, whereas the large scale fading occurs over a larger distance and there is an obstacle comes in between a transmitter to the receiver where there is a large fluctuation of the signal occurs. Here we are including the effect of path loss and shadowing. For better understanding of this video, kindly take this assessment. Thank you.